Okay, looks like we're up and going. If you're here, just let me know, like you usually do. Ooh, let me mute this actually. Okay. Looks like David's here. Hi, David. How are you doing today? Hi, Natalie. Um, like always, we're just going to wait a few more minutes for everybody to roll in. But as we're just waiting here, I'll just talk about the various things we're going to talk about today. So the first thing I want to talk about, obviously, last week we were talking about Raycast a bit. This is a, like, what's the word I'm looking for? I don't know, but it's very important to know about Raycast because they're very useful for a variety of reasons. And for David's project in specific, we were having trouble detecting the food on the table last week in your project. Like when you walked up to the table and tried to eat the food, sometimes it wasn't. Okay, it looks like you found the bug, but we're going to show you anyway because Raycast is still very useful. But at least from last week, it seems like there was trouble trying to eat the food. So using a Raycast, I'll show you a few different ways to use Raycast. There's a regular Raycast and a Raycast array where you could get. Okay, yeah, as Natalie said, Raycasts are just good to know. But like there's regular Raycast, then there's like an array of Raycast. Because just a basic Raycast is gonna shoot out just like a beam, and the first thing it collides with, it's like, okay, I collided with this. But let's say you want to know everything that's within your line of sight or within the Raycast laser, you have to use an array for that, and then you could sift through each of the elements in that array to pick and choose which, like, the things you actually care about. So, for instance, with the burger, I would prefer to use an array for that, because as long as you're within range and you're looking at the burger, you should just make it so that you could eat it. Because for whatever reason, let's say maybe the chair collider is peeping out a little bit. Like, let's say you're at this angle and the collider just pokes out a bit for the chair. Like, you're looking at the burger, you see that you're trying to eat the burger, so you press the button to eat the burger, but because this collider is just peeping out a little bit, the Raycast is going to hit that first, so it won't register you eating the burger. Whereas if you had the array, it would hit both of them. So you could be like, if in this array, the burger is one of them, then you could eat it. So I've been talking about this long enough. I'm just gonna get started. So the first thing we're gonna do is just make a Raycast. So on the FPS controller, which is the logic, we have the player. I'm gonna make a new script just because these two base scripts that the player already has are pretty long to begin with. So we'll just make something new, just to keep it all nice and concise, and so you could just easily see what I'm doing. So we'll just call this Raycast logic. Ooh, okay. When I was testing this earlier, looks like it remembers, but we'll make a new one called Raycast logic. So we got our script here. Ooh. Open it up. So, actually, before I get started, I just wanted to show you guys, as we usually do. Well, as we talked about a couple months ago in class, you could always look these things up. So I just want to point out that what I'm going to teach you now is right here on the Unity forums, just in case you ever forget or you don't feel like watching through this entire stream just to learn about Raycast. You could just quickly look here. Obviously, this is going to be a bit confusing to you right now, but hopefully after I explain it, once you come back to this, it'll make more sense. But essentially what we're doing is we're going to make a Raycast, and then we're going to check to see if the Raycast hits something. Then if it does, we're going to do something inside of the if statement. It's a little bit more complex than that, but that's just the gist of it. So, just so you know, you just type in Unity Raycast, and this will be the first thing that pops up. So as for actually making them, I'm going to go in here. In update, we're going to make a Raycast hit, and we're just going to call it hit. This is going to store the data of what we're hitting, like the raycast is hitting. So once we have this, we're going to make our if statement. If physics dot raycast. So this takes a couple parameters. The first parameter is going to be the position of, like, the position the raycast starts at. So we're just going to do transform.position. Just going to be at the player's transform.position. Then the next thing we're going to do, well, actually, like, different functions have multiple amounts of arguments. So if you just look at this, you'll see the next one's max distance. But the one we're going to do isn't just going to be max distance, because we actually want it to point in a direction. So the next argument is going to be the direction. So we're going to do the direction the player is looking at, which is as simple as just doing transform.forward. And transform.forward, if we go back here and we go to the player, you can't really see a physical thing for the player because we don't have one. But just for all intents and purposes, transform.forward, it's just going to give you like wherever this blue arrow is pointing, because that's just forward. The blue arrow is forward. The red arrow would be, if we go back here, we did transform.right. That would be the red arrow. Then the green arrow, if you wanted to check above you. Oh, hi Tayshawn, how are you? So then if you want to check up, that's just up. And if you wanted to get the opposite directions of each of those, like let's say you, instead of doing directly in front of you, you wanted to do behind you. Instead of doing transform.forward, it would still be transform.forward, but you would do negative transform.forward. And then that would get, we'll shoot a raycast behind you. But we want to shoot a raycast in front of us, so we're just going to do transform.forward. And then after that, out, hit. Basically, the thing I collide with, we're going to store it inside of hit. That's what this means. And then after this is going to be the length of the raycast. It's like how far it shoots out. For some purposes, we want it to be infinite. For others, we don't want it to be infinite. For example, if we wanted to open this door, you don't want it to be infinite. So if I'm standing all the way back here, where the player currently is, I shouldn't be able to open the door from all the way back here. So you would use a smaller distance, like shoot the stream is frozen. Can anybody else let me know if the stream is also frozen for you? Because then I'll wait a bit. Okay. Do you also see what I'm doing, or can you only hear me? Okay. Tayshawn, I would try to just refresh your browser, maybe. But, so hopefully that'll work. So just try refreshing Twitch. Maybe it's just acting a bit buggy on your phone right now. Or it's just your phone, yeah. But hopefully that gets resolved. But as I was saying, with distance, we want it to be shorter if we wanted to do the door. That's pretty much all I want to say. And the units of measurements being used here are going to be the unity units. So that's just an arbitrary unit of measurement that Unity uses. So I'll show you what one unity unit is in a sec. But we're just going to make this... Okay. We'll just make it 1. And then we'll do our curly brackets. So now we have our statement here that's going to check... that's going to shoot the raycast out and store whatever it hits into hit. So in here, we could do various things, but we're just going to shoot... We're going to... You could use debug to actually show the raycasts. So that's what I'm going to do, just so you can physically see what I'm showing you right now. So in order to do that, you do debug.draw, right? And the arguments are going to be relatively the same for this. It'd be transform.position, which is the position it's going to start shooting out from. Then there's going to be transform.forward, which is the direction. But one slight thing with the debug is there's no distance argument. The way you get distance would be to multiply the distance. Multiply the direction by the distance. And actually, now that I look at this, we should make distance a public variable so that we could just easily change it in the inspector. So distance, and then distance. Then after this, we're just going to do a color. Okay, it seems that Tayshawn's is working now. So you could just type in, you could get the hex value, or you could just do color dot, and then we'll have these different colors come up. For debug, I prefer red, but it doesn't matter. And then if we hit play, in the editor, you should be able to see a raycast actually shoot out. So we start the game, and just so you guys know, when we do debug.drawRay, it's not going to show in the game window, it's going to show in the scene window, because it's a debug, not actually part of the game itself. So we hit play, and let's see, jump. Actually, wait, let me take it out of that if statement. Oh, yeah, that's what I did wrong, because we want to take it out of here. Otherwise, it's only going to show if I'm hitting something. My bad, sorry about that. Oh, okay, yeah, that's also one thing you should note. Make sure gizmos are on. If you look on the top right over here, gizmos, when it's a lighter color, that means it's on. This means it's off. So that's another thing to note. But yeah, I just had the debug in that if statement. So check here. Although, let me check this. Ooh. Oh, I'm dumb. Ahaha. I forgot to set the distance. That's why. Okay. Okay, we're gonna restart this. Put the distance in this time. Okay. Okay. So now you can see. Sorry about that. You see the line. This is the debug.drawRay. This is just a physical appearance of. This is a physical appearance of the ray that is shooting out. And as you can see, this is what one Unity unit looks like. Like I said, it's an arbitrary unit of measurement that Unity uses. But in case you're curious just roughly how long one Unity unit is, it's that long. So, one thing to note here though, is if you see, the ray is shooting just from my body and not necessarily where I'm looking. So that's another thing we have to keep track of, is we don't want the ray just to cast from itself. We want it to shoot from the camera itself. Because otherwise it's not going to track where you're looking, it's just going to shoot in front of you. So that's one thing I wanted to point out to you guys. So now that I pointed that out, we're going to actually add it here. So we're going to add the camera now. And instead of doing transform.position, we're just going to do main camera.transform.position. And same thing with the transform.forward. We're going to do main camera.transform.forward. And same thing with the debugs. Main camera. Okay. So now that I've done all that, it should shoot from the camera, because the camera is where we're looking, and it should follow the direction of the camera wherever we're looking. So let's hit play and see if it works. Oh, I forgot. I always forget to add these inspector elements. But okay, here we go. Put the camera in, and then let's do it. Okay, so now you see that if we go over here, you'll see the raycast is now shooting out from the camera. So it's the raycast is being shot wherever I look. So this is useful for a lot of things. Because if you're doing a game that's first person, you want to make it so that you could interact with your environment. And if the raycast isn't shooting out wherever you look, the interactions are going to just feel a bit off, because it's not going to be exactly what you want it to be. So make sure if you're doing a first-person game, you have the raycast being shot out of the camera and also following the direction of the camera, which again is just doing the main camera transform.forward, and forward is just gonna shoot it whatever way it's looking. So now that we have that, let's actually talk about what we can do with these raycasts. Like, okay, I shot a raycast out, but what can I do with this? So we're just gonna make it so whatever I'm looking at, it's gonna tell me the name of that object. Obviously there's more you can do than just that, but I just want to show you the versatility of it. It's effectively whatever I'm looking at, I could get any component from that, I could call different things from that component, and all these things. So let's make a public. Before we do that, we need to import it using UI. And we're going to import tmpro because that's the text I prefer to use over the default text. So let's make a public text mesh pro UGUI, and we'll call this name of object. And right in this if statement, we're going to set name of object equal to, and now this is the first time we're actually going to use anything that the raycast is hitting. So the way we do this is we do hit dot transform dot name. So, and we got to do dot text. So as you can see, when we shoot this raycast out, we're storing the transform. Well, we're storing like the thing itself, whatever we're hitting with the raycast, into hit. So the thing we're hitting, its transform, which is this here, dot name, which is going to be the name right here. So whatever I'm looking at, it's going to give me this name, and it's going to set the text we just made, the text, like the string of the text, equal to that. So let's actually make the text now and see if it works. So UI text mesh pro, call this object text. Just put it, let's put it in the top left corner. We'll change the anchor point. Go to canvas, make sure right now it's constant pixel size. Let's scale with screen size. And once we have that, let's also extend this out. Make it auto size so that way if the name is longer, it'll still fit within the box. And just change the max value of that to something smaller. Okay, that's good enough. The text itself doesn't matter that much. We're just showing an example. So we'll put this in here now. And let me just double check I did all this right. So we're just changing the text equal to that. Okay. So I'm gonna hit play. So let's walk up to something. So actually one thing I'll do, let me make the distance a bit longer, just so I don't have to be right up to it for it to register. So as you can see, it's now giving me the name of whatever I'm looking at. So if I look at the pantry, let's just come back here, and I click on the pantry. Pantry, you see the thing I'm looking at has this name PFB pantry, and that's why in here it's telling me pantry. So I'm getting that component from it because I'm looking at it. This is what's stored in hit. We're doing hit.transform.name, and it's going to give me the name of whatever I'm looking at up here. So that's all fine and dandy, but getting the name of something isn't really that helpful. It could be, but we don't care about that. Let's do something more fun. Also, it seems hamburger is spelled incorrectly. We'll change that. Not that it's a big deal, but okay. Hamburger. So let's do something a little bit more like engaging. So what if we make it so whatever I'm looking at, if I click the mouse button, let's just destroy it. Why not? You know, there's different things you could do. Like, let's say you click, oh, creates a particle effect. It's like, oh, okay, but we're just gonna destroy it because why not? Just to show you that we could play with these things in various ways, just from registering the raycast itself hitting something. So we could do raycast, and then again we're going to do hit that transform dot game object. So we're just going to destroy the game object of whatever we're hitting. And let's also make it so this is going to be when I click, otherwise it would just destroy everything I look at. So we're going to make it so on click it's going to destroy it. So if input dot get mouse button down 0. So I forget off the top of my head what 1 and 2 are. Obviously, well, actually I do know. It's middle click and right click, but I forget which one's which. But mouse button 0 is left click. So that's all we care about. So once I click on it, whatever I'm looking at is just going to get destroyed. So let's just test that out. So we're going to look at the pantry. We click. Oh, I destroyed it. So if you wanted to do something more fancy with that, you could add like a cool explosion effect. And if you want to add that, you would just do hit.point. Hit.point is just the transformed position of wherever the contact is. So just so you know that. But we're just going to destroy stuff. So as you can see, whatever I click on, it just gets destroyed. So I destroyed the floor, whatever. But okay, so we're making progress, okay? So we're destroying things now, but now we're destroying too many things. We only want to destroy the hamburger. So as I said, you can get various things about the objects that the raycast is hitting. So what I did is I added a tag called food. So what I'm going to do is, if the tag is food, and I click, and the raycast is on it, then I'm going to destroy the food. So we already have most of that written already. So if I'm looking at it, if I click the button, and we're also going to check if hit.transform.name is equal to food. So in David's case, this is pretty much exactly what you would do in your project. Just because you have French fries and hamburgers, you could just use the universal tag for... Yeah, as Natalie says, you could also use this as a way for the character to pick up the box. But you could just put the food tag on the fries and the burger. And in here, because obviously you want to destroy it, you could also increase health for your project in specific. You would also put that code here. So let's run the game again. So as I click on various things, they should not get destroyed because they do not have tag food. As you see, nothing's happening when I click on it. But if I go over to the burger, click on it. Oh, looks like it didn't work. Okay, what did I do wrong? Let's see. Oh, okay, never mind. If hit.transform.tag, not name. Sorry about that. The name is this up here. The tag is the tag. So, sorry about that. A little mess up right there, but it should work this time. So now we go over here. Whoa, it disappeared. And everything else I click on doesn't disappear because we only care about the burger. So that's just one thing you can do. The next thing I want to do is show you how to make an array of raycasts. So, because sometimes it's nice just to be able to get everything within a line of sight. So I'll just show you that. It's just another thing to know about. I just want you to know that they exist. You don't necessarily have to be an expert at using them, or even have to use them in your project right now. But just knowing they exist in the future, if you ever need to use it, you know it's a thing. So it's slightly different the way you write things. So this is going to be an array, as I said. So we have to do these brackets. And instead of doing this if statement, we could actually save hit outside of the if statement, which you can't really do if it's not an array. So we do hit equals physics dot raycast, and you see in the first one we used the raycast. We're going to use raycast all now. So raycast all is going to store everything within that the raycast is hitting, so within the line of sight. So raycast all, and once again all the variables are going to be pretty much exactly the same. So it's going to be position. So we still want to do the camera dot transform dot position. Then the angle, this is going to be main camera dot transform dot forward. Then we could put a distance. And let's see, what did I do wrong here? Oh, yeah, it's not curly brackets, my bad. And you'll see that this one is slightly different. This one does not have out because it's not setting a single thing to hit. It's storing everything. So we don't need the out argument because all of it's just going to get stored into hit, if that makes any sense. We're still going to make the draw ray, but we could get rid of this if statement because this is for a single raycast, whereas we're doing a multiple hit raycast now. So instead of this, we're going to do something slightly different, and this is something I talked about in a previous week, which is a for loop or a for each loop. So in the previous weeks, I mainly focused on a for loop because getting the index of something is very important, but in this case, we don't really care about the index. We just want to make sure whatever we're looking for is within this this array of raycast. So we're just going to do a for each loop because a for each is just going to run through everything. It doesn't care what the index is. It's just going to go through everything. And for each loops take different arguments. The first one is going to be the type of whatever we want to get. So it's going to be type raycast hit because we're getting the raycast. So hopefully this makes more sense once I fully type it out. And I'll go over it once again once I do. So raycast hit, and then we're going to make a variable name. So this could be whatever we want it to be called. So objects hit. So raycast hit, then the word in, just in, and in hit. So we're just going to run through every instance of the thing. So each raycast, because, okay, I'll start that over. An array is an accumulation of whatever data type this is, as I've said in previous weeks. So because its data type is raycast hit, it stores multiple raycast hits. So now in here, we're going to run through each raycast hit that's in hit. Hopefully that's not too many hits in one sentence. So hopefully that makes sense. So now what we're going to do here is, I'll just rewrite the code. So instead of using hit to reference the thing we're hitting, we're going to use objects hit. So we want to check if objects hit, and the way you write out the code is the same as hit, but the variable name is going to be objects hit instead of hit this time. So objects hit dot transform dot tag equal food. Okay, there we go. So basically, it's just going to run through everything we're currently hitting, and if any of them have the tag food, then we're going to run destroy objects. I can't spell. Objects hit transform game object. Okay, and I believe I wrote that all out correctly. Let me just double check. Yeah, it should all be good. Okay, so let's run this again. Hit play. Oh, actually, let me do the input one more time. So we also want to check if we're clicking on the mouse. So if input dot get mouse button down 0. Again, 0 is going to refer to left click. So go back here, run the game. So as you can see, the text is no longer updated on the top left corner. That's because I didn't adjust it for the new way I'm writing the code out. But as you can see, it still runs functionally the same. And one more thing I'll actually point out to you is, well, not point out, I'll show you. With this text that we don't have updating anymore, I'm now going to print out everything that it's colliding with. So instead of just having one thing there, we'll just have everything. So all the possible things that I could possibly interact with based on the line of sight I have with my raycast. So what we'll do here is, for each, we're just going to do name of object dot text plus equals objects hit dot transform dot name. And what we're going to do after this, if you've never seen this before, with strings, there's some built-in, like, string characters that do various things. Honestly, forget the name of them, but next time, I'll try to remember the name of them just so I can show you the different types, because these are also useful. If you do, what's wrong with this? Am I missing a semicolon somewhere? Get rid of this. Where am I forgetting a semicolon? Destroy. What am I forgetting? Like, this wasn't there if I... Oh, it's up here. I accidentally deleted this one. Okay. Sorry about that. Okay. So let's just write that out one more time. Object. Name of object. Dot text is equal, well, plus equals objects hit dot transform dot name plus this. Yeah. Okay. Sorry about that little delay. But what this does is, this is a built-in thing. This just means go to the next line. So this is the same as hitting the enter key. There's different types of these. There's tab. So this hits the tab. You could also do backslash backslash, because if you do a backslash, it's going to signal that it wants to do a special character. So it's impossible to write a backslash unless you put a second backslash, because the first backslash is going to delete itself so that it could run the special character, and then the special character is just going to be backslash. So hopefully that's not too confusing. But like, as you see here, like, this isn't going to actually print anything, it's just going to go to the next line. The backslash is just an indication that we want to check a special character. The special character in this instance being n, and n just means go to a new line. So hopefully that makes sense. And the reason we want to do this is because as we run through each of them, we want each of them to be on the next line. So the first the first thing the raycast is hitting is going to be at the top. It's going to go to the next line, print out the second thing we're looking at, go to the next line, etc. The last thing we want to do is, before we do all this, we just want to set text equal to nothing, because otherwise it'll never refresh itself. So that's that. I think that's everything. So let's run this. Hopefully it works as intended. Okay, so as you can see, I'm looking at multiple things. So what it's looking at, I'm looking at the table, then it's checking, then it's looking past that, I'm looking at the floor, like the floor of the house, and then after that, underneath the house, is the actual terrain itself. So this is the terrain. So, as you can see, it's going to run through everything I'm looking at, and just get all of them. So, this is useful for the next reason I'm going to tell you, which is, I'm going to do a thing where this might be useful in your game, David, because you had a thing where you had an invisible wall over here, because you don't want the player to leave, obviously. Like, you don't have to do this, it's just another workaround. What I'll do is, I'll put a invisible barrier around, just as you did. But as I approach the barrier, I'm going to have an overlay on top of the camera that's just going to be like red. Then as you get closer to the invisible barrier, the red is just going to gain opacity. So that way it becomes more visible until you're right up to the collider, and then it's just, you can't see anything. It's just pure red on your screen. And then I guess in theory, once you reach a certain point, you could just kill the player, do nothing, just have the screen be red, or just take them back to the beginning of where they started, like over here. Is it going to be like the pack game? I honestly don't know that game, so I can't tell you. But oh no, actually no, the pack game. No, that's the game we played. Yes, it's going to be just like that. Sorry, I just forgot the name off the top of my head. But yes, it's going to be like that, where as you leave water, the screen around you is going to fade. Not fade. It's going to like just make you feel more claustrophobic. Basically incentivize the player to turn around and not continue going that way. So the first thing we'll do is we're going to actually create the invisible barrier. So excuse me while I just create a few things here. Put this here. Box collider. Make a really big box collider. That's just going to surround this entire building. So that's one. Copy and paste. This one we're going to put over here. Put another one. Box collider. Do that. Okay. Almost there. But basically, as I said, as we approach these, call them bounds, it's just going to make your screen go more red. And just one more. Copy, paste. And put this one right there. It's hard to see the barriers because they don't have physical properties to them, but okay, so that's that. The first thing we want to do is, hopefully it's not too close, whatever, that's good enough. We can make these triggers, or I guess in this case a trigger would be better. Nah, we'll do not trigger. Okay, so we're just gonna give it the tag bounds, which I already made. So basically, if we're gonna walk into the bounds, we're gonna do some logic that's going to make the screen go like opacity red. So the next thing we need to do is actually make that. So we need to make a new image. Click on it. Make it really big. Take up the whole screen. Make it red. That's an obnoxious color, but it's supposed to be obnoxious. And then we'll just turn the opacity all the way down. So the next thing we're going to do is actually go into the code and make this work. So we're back in Raycast logic. First we need to do is make a public image, we'll just call it red overlay. This is going to be the image itself that I just put here that is now invisible. So this one. And in here, so we have one if statement that's checking if it's food. The next thing we're going to do is, outside of this, we're just going to check if we're hitting bounds. So if object hit dot transform dot tag equal bounds. So we're checking if it's bounds. We don't care about a mouse click because we just want to see all the time if the player is approaching a bound area. So if any of them are bounds, actually, I might need to do something. No, I don't. Okay. So we have this. The thing I want to do is we're going to use the percentage formula once again. I've talked about this in the past, but the percentage formula basically gets you a percentage of how close you are to something, or how close something is to reaching something. So let's say the current number is 50, and you're trying to see how far away you are from 100, it would give you 0.5 because you're 50% of the way to 100. So there's a few things we need to know, which is the formula itself. So the formula itself is current value minus the minimum value divided by the max value minus the min value. So what we're going to do, I'm showing this. Okay. The current value is going to be the current distance you are from bounds. So we don't care about this. Well, I mean, we don't care in terms of, I'm going to comment what the different things are. Actually, whatever, I just write it. So current value is going to be the current distance from bounds. The minimum value is going to be the distance. Actually, let me just double check if that's right. Yeah. Okay. So we're going to have the ray length, which we have up here. Distance. Actually, let me rename that because I'm going to call something else distance. So this is the ray length. Replace all these. Okay. So the minimum value is going to be the ray length. So essentially, okay, so if you could imagine this, as I'm here, where's the front? Okay, the bound is roughly right there. So let's say I'm 5 units away, because that's how long my ray length is. Let me hit save. Okay, that's how far the length is. So if I'm 5 away, that's going to be the minimum value, because that's when it first starts registering that it should do any of this logic to begin with. So once I'm 5 unity units away, I'm going to be hitting the bound collider because I'm within range. So that's why it's the minimum. And then as I approach the bounds, the distance is going to get less and less until it's 0. So the maximum value is going to be 0 because that's when you're closest to it. If that makes any sense. Because if we look at the percentage formula, as I approach the bounds, which in the last example I did with the 50 and 100, like the number is going to get closer to 0 as I get closer to the thing. So that's why it's like that. So max is going to be 0. So it's just straight up 0, because when distance is 0, you're just right there. So let's actually use this information to like do something. So what we do is, let's make a new color. We'll call this the red overlay color equals red overlay dot color. The reason we're saving this separately is because you can't directly access the alpha component of a component. Well, the alpha argument of a component. So if we go back here and we go to color, you'll see there's 4 arguments, which is RGB, so red, green, blue, and the 4th argument is alpha. You can't directly access alpha, so, well, from the components. That's why I'm creating a new one, because once I create a new one, I can now do red overlay color dot A, which is alpha, is equal to whatever. So we could hard set the alpha once we make a temporary variable of the color. So now that we have that, we want the alpha to be, actually we need to get the distance first. So let's use our distance formula. So float percentage is equal to, actually one step back. Let's get the distance first, so that our percentage formula isn't a big jumbled up mess of a really long code. So we'll minimize it by getting the distance first and then using the distance in the formula separately. So we'll do that first. So distance, float, distance. Creating a new float called distance is equal to, it's called vector3.distance. So vector3.distance is going to calculate how far away 2 objects are from each other. So the first argument of this, it takes 2 arguments, is going to be the other thing. So in this case, the other thing is going to be the bounds itself. So it's going to be objects hit, because we're running through this for loop, well, for each loop. So if the thing we're hitting is bounds, we're going to get objects hit dot point. I mentioned this earlier. Objects hit dot point is just the transform dot position of the contact between these two things. So the point is going to be when my raycast hits the collider bounds, right in that position is going to be where it's going to start calculating. So there's that, and then there's going to be my position, which is technically the camera, because we're shooting the raycast from the camera. So we're doing main camera dot transform dot position. So this is going to give us the distance between our 2 points, but the one thing we want to do is we want to make sure this is absolute value. So as you probably already know, absolute value just means if it's negative, make it positive, because we don't care about negative or positive. We just want to know the distance. So negative or positive, that's going to mess up our formula for later. We just want to know the straight distance itself. Well, the difference between the two. So we're just going to do math f.abs. ABS stands for absolute value. So we got our distance. So now we can actually do the percentage formula. So if we look up here, current value is the current value, as the current distance. That's going to be this right here, distance. Then after that, we're doing minus the minimum value. Minimum value is the ray length, which we have called up here, ray length. So ray length divided by the maximum value, which is 0, and subtracted by minimum value, which is once again ray length. And I believe that is correct. Let me just double check. Distance ray length. Okay, that's good. Okay, so once we have this, we will now set the alpha equal to this percentage. So once again, if we're at the furthest point of collision, which is 5 units away, alpha will be 0. Well, technically like 0.0001. So barely noticeable. Then as I approach 0, the percentage is going to get higher. And then if you're really close, it's going to be 100%. So alpha is going to be equal to 1, because 100% is just 1. And alpha works the same way. It's 0 to 1. So is that. So we're just going to equal percentage. Yep. And now this is just a temporary color. So we now have to apply our color back to the image. So we call the image red overlay. Red overlay dot color is equal to red overlay color. This is our temporary one. So we're just going to set it equal to that. And I think that's it. Let me just check something real quick. Oh, okay. One more thing that I did in this little thing I'm looking at, because I did this earlier, just to have it all ready. We also want to set it back to 0 opacity once we stop looking at it. So what I did is I created a list that stores them all. Well, actually, I don't even need a list. Just before we do this, we're going to create a temporary boolean. Actually, up here. So bool is within bounds range. So by default, I'm just going to set this equal to false, because we're just going to assume that we're not within range. But if we are within range, which is when this gets called, we're going to set is within bounds range equal to true. And then if it's true, that's all fine and dandy. We'll just not do anything else. But if is within range is not true, so if it's false, we're just going to set the color, well, the opacity back to 0, because we don't want the overlay there anymore. So we'll take this. We could just copy and paste this and get rid of what we don't need. We don't care about this. We're going to set this equal to 0 and then reset it. So that should all be good. We just wrote a lot of code, so hopefully nothing breaks. I'll make sure to put all the inspector elements before we actually start. So we need the image, which is this one. I believe. Yes, okay. So, oh, and, okay, that's good. Okay, let's see if this actually works. Open this. And nothing is happening. Let's check. Where is the cube? Actually, let's make these physical. I can't see. So it's all the way over here. And where is the player? This way. Okay, so the collider is here. I must have messed something up though. Which I wonder... Oh! When I changed the name of Ray Link, it's set back to 0. Oh, good job, Dan. Okay. Hopefully it'll work this time. Boop, boop, boop. Oop. There we go. Oh, okay. Okay, it is working. So, as you can see, you can't really see the bounce, but as I approach it, it's slowly getting more red until eventually I can't move anymore. Now that I think about it, let's make this a trigger so that way we could walk through it and I can show you the full opacity effect. And let me just extend this out. Okay. Try it one more time. Sorry about the delay. Let's open this door. Okay, so as I approach this, it gets more red. And then... I guess once I walk through it, it doesn't red. Oh, because I'm inside of it. Okay. Well, that's unfortunate. I feel like I should still register, though. Let's see if I could expand it. Put this more down. Okay, well, I guess one thing we can do is once it's at max opacity, we could just tell it to stay at max opacity. And then once we leave it, then we could set it back. But you get the gist of it. That's all I want to show you, is as you approach it, it's getting more and more red. So that's another thing you could do. A fun thing you could try. Or what you could do is once it reaches max opacity, you could just reset the player back to the beginning. So it doesn't necessarily matter if you could walk through it, because once you walk through it, it doesn't matter anymore, because you're not supposed to go that far. It being at max opacity is the same as telling the player they can't go this far anymore. So that's what I want to show you with that. We're running slightly behind schedule, or I just have more that I wanted to talk about. So we'll quickly go on to the next thing. So that's your little tutorial on Raycast. As I said before, just look up Unity Raycast, and this will come up if you ever forget. But the next thing we're going to do is just a small bit of polish that we could add to various menus or whatever. So we're going to go back to main menu, and if we just hit play, we'll see. Let's make it big. These buttons are pretty lame. Like, yeah, they work. Like, you click on it, it goes to the next scene. But that's boring. These buttons don't really do anything. So how can we make this more fun? So the first thing I'm going to talk about, I'm almost certain you already know about this, but I'll just say it again just in case you don't. Let's go back to the front. Ooh, okay. So if we click on the button, you'll see there's different things here. There's the highlight color, select a color, disable color, whatever. So if we go to highlighted color and we change it to yellow, go back here. So when you highlight over it, it's now yellow. So this is an improvement. We're stepping up our game. But as you can see, I didn't do that with the rest of them, so these are still boring. But we'll just do it one at a time. So now you hover over it, it's yellow. Oh, that's crazy. But we can do better. The next thing we can do is... Actually, one thing, I sort of prefer just to change the text color itself. I feel like that looks slightly more fancy instead of just changing the whole button. But that's personal preference. But in the event we want to do that, let's make a UI script, UI events. No, I want to make a new one. Oh no, okay. UI events. And in here, I'm just going to make a various amounts of functions that just do various things just for the UI. So in this case, we're just going to change the text color. So we need to import Unity Engine.ui and TM Pro because I like Text Mesh Pro. So let's import a public Text Mesh Pro. And just so you guys know, I'm going to be going over the 5 o'clock time. So if you want to leave, I guess you could leave. But if you want to stay, I'll be here a little bit longer than 5. Text Mesh Pro, UGUI. This is going to be the text of the button. So we'll just call it button text. And one little fun thing you can do if you don't know about this, if you do a public color, you can choose a color from the inspector. So this will be the text color on highlight. So we'll go back here and wait for this to load. And you can see I could change the color. So let's change the text color to yellow. And also by default, color sets opacity as 0. And I don't know why. And I sort of hate it because so many times I'm like, why doesn't this work? It's because by default the opacity is 0. So make sure you make it not 0 so that you could actually see what you're doing. But let's make, so this is going to be the text color when I highlight over it. And then we're going to put the text in here. So the text is like the text, obviously. So now let's make a function that actually tells the text to change color. We'll keep those. We might need them later. So let's make a new function called public void on, let's just call it on hover. So on hover, we're just going to change button text the color equal to text color on highlight. So we go back here, and the next thing I want you to know about is it's called event trigger. These are really helpful because there's a ton you could do. Event trigger. If we open up, so we have this. You could add a new event type, and if you click on this, you'll see there's a ton of things you can do. I'm pretty sure I talked about this already, but I'll talk about it once again because they're really helpful. Different things you can do. Some of them are self-explanatory. We care about on pointer enter. So when the mouse enters the button, we're going to call our function to change the text color to yellow. So we're going to have this here. It makes a new thing here. We add the plus button, and you'll see this. We drag and drop our script onto here because the script contains the function that we want to call. So that's why we put the script in here, and then we go to this drop down, the script we just put in there, which is UI events, then on hover, which is the function we just made. So on pointer enter, when the mouse enters the button, I'm going to change the color to yellow. But you'll notice when I leave, it doesn't change back. That's because we have to store the original value or just have a public original value. We'll just do the public original value just so that, whatever. No reason. It's preference, but original color. So now on here, we'll do on hover exit. I guess I poorly named that last one. I should have called it on hover enter. Okay. Okay, so on hover exit, I'm going to set this color equal to original color. And it's as simple as that. Now we go back here to our event system. You could add multiple things to the event system. So we're going to add a new one. On pointer exit, this is when the mouse leaves the button. We're going to do on hover exit, And let's set the new color and make sure you make the opacity not 0. So actually the default one should be black. Okay. So when my mouse enters, it's yellow. When it leaves, it's black. Although it's slightly different, the default color is that other color. But we could get nitpicky. But it doesn't really matter. This isn't what I'm trying to show you. I'm just trying to show you. You could do that. But there's more I want to show you. It's crazy. So the next thing is, let's make it so that the text does a little grow and contract thing as you hover over it. So as you hover over it, the text is just going to grow and shrink. It adds movement to the game. And having movement in your game just makes it feel more alive. It makes it feel better. Sorry about that. Okay, so movement to your game makes it feel alive, makes it feel better. Try to add it wherever possible. In this case, we're going to use a sine wave. And I'll just bring up a sine wave. I'm sure you know about it, but sine wave goes up and down. So basically, we're going to change the scale of the text based on this sine wave. So as it goes up, the scale increases. As it goes down, the scale decreases, making a growing and contrasting effect to the text itself. So let's go back here. Open this up. Let me just bring something up real quick. Just as a backup. Okay. So go back here. And let's make a public. Actually, we don't need public. Private bool is hovering. So when the mouse enters the button, we're going to set hovering equal to true, because the mouse is now over the button. So is hovering equal to true. And once it exits, is hovering is equal to false. And now in update, if it's true, we're going to expand and contract the text. So let's do that now. If is hovering, we are going to do button text. Actually, would it be button text? No. Okay. It would be. No, it would be button text. So button text dot game objects, because let's go back here just so point everything out to you. So this is the Text Mesh Pro. That's what this is. Text Mesh Pro. That's what button text is. It's this right here. Doing dot game object means the whole thing, and then we're going to change the transform dot position. I mean the transform dot scale of that, so that way we could expand and contract it. Hopefully that makes sense. So dot transform dot local scale is equal to new vector 3. If you look at scales of things, it's a vector 3, so it takes 3 arguments, the x, y, and z. So that's why I'm doing a new vector 3, because we're going to change each of these. One thing I just realized, I need to store the original size of this text, so that way it has the base value, and then as the sine wave goes up and down, we just add and subtract from that original value. So we do private vector 3 original size, and in start original size equals button text dot transform dot local scale game object dot transform dot local scale. Okay. So now that we have the original size, we can now put stuff in here. So what we do is original size dot x, because like I said, vector 3 has 3 arguments. There's the x, y, and z. So we're starting off with x. So from that, we're going to add our sine wave to it. So plus, in order to get a sine wave, you do mathf dot sine. So we have our sine wave. Now, if we look back at the graph here, as time increases, it runs through the sine wave. So we have to give the argument of time to this right here, so that way the number increases and decreases based on sine wave. So to get time, you just do time.time, and that'll just do as time increases, it's going to run through the sine wave. This is not to be mistaken with time.delta time. This is a different thing. Time.delta time basically just gets you the difference in time between the last frame and the current frame, roughly the general gist of it. Time.time is an overall value, so this is going to be continually increasing, whereas time.delta time does not continually increase. It's just a small time that just gets the time between the last frame and the current frame. So that's that little explanation there. And there's a few things we need to play with here. So I'm going to add some modifying variables here, which is going to be the speed. So it's going to be the speed that it runs through the sine wave. Then we're also going to do public scale. Public float scale. It's going to be how much the sine wave goes up and down. And then lastly, there's the intensity. Public float intensity. Okay, I lied. Intensity is how much it goes up and down. Scale is, you want to set a default range, sort of, so that way it doesn't go all the way down to 0, because that looks weird if your text just goes down to scale at 0, because the text just disappears. You want to set a default variable for, or value for the text, so that way it doesn't decrease past a certain point. So that's what scale is going to be. That's going to be like your default scale, and then intensity is going to amplify based off of that. So we have our time.time, then we're going to multiply that by the speed, because time.time runs in linear time, so if we multiply that by speed, it'll run through the equation faster. So that's the first thing. Second thing is we increase the scale to this. So, like, okay, if we go back to our sine wave, as you can see, it goes all the way down to here. So if this is the base size, the base scale of our text is going to be down here, because our base scale is 1, and the default sine wave goes from 1 to -1. So it'll be all the way down here, making the scale equal to 0. If we add a base number to it, it'll just raise the whole equation up, so that way the base point isn't equal to the current scale, which will make it equal to 0. So hopefully that makes sense. We're just raising the whole thing up, so that way the baseline is higher up. So that's why we're adding the scale to this. And the last thing we do is multiply the entire thing by the intensity. And we need to put proper parentheses. So there's going to be and put this one on here. And yeah, okay, that's good. So now we just do this 2 more times for the x and y. So I'm just going to copy and paste this whole thing. So there's that, and there's that. And put that there. And semicolon. And now we just need to make sure we change the things for y and z. So we do that. That's good. Now once we do that, actually that's all we care about. But if it's not hovering, we just set the scale back equal to the default scale. So we do this equal to original size. So if we're not hovering over it, we're just going to set it back to default size. And if we are hovering, it's going to go in between it's going to go through the sine wave, essentially. So I think that's all good. Let me check if I wrote down the variables I used for each of these, because obviously you could play with these to your liking, but just to quickly show you just what a nice one looks like by default, well, somewhat nice. We'll go here, we'll go to the speed, and for speed, put 5 scale, I had 1, and intensity I had 0.2. So I think these are good numbers. Let's see how it runs. Okay, so as you see, I hover over it, and it's just going to run through the sine wave. So one thing I'll just show you, if I set the scale back to 0, if I don't have that offset, it's just going to go down to 0, which just looks bad. So go back here. Oh, actually it doesn't. Wait. What did I mess up? Whatever. Okay. It's going to increase it anyway. So I lied about it going back to 0. That must have just been the numbers I had in that particular instance. But whatever. See? Okay. Now it's a little bit more lively. Your menu looks slightly better, in my opinion. So that's why I wanted to show you with that. Not a huge change. We're almost done. I just want to point out 2 different YouTube presentations, I guess, that will help you a ton in terms of juicing up your game. These talks are, well, one of the talks is super well known in the gaming community, just because, I guess, how accurate it is and how simple it is to just make your game feel better. And then the second one, just one that I personally like. It has a lot of good advice to make your game just feel better and more lively. So we'll talk about that. I have them brought up here. So the first one, we'll talk about this one. This is the bigger one. This is a talk called Juice It or Lose It. This was a talk that they had at, I believe, GDC. I could be wrong. I forget where it was, but it was at a gaming conference. And basically, it's a pretty long, actually, it's not that long. It's only 15 minutes. I would advise you look at it. It's really good, I promise. It's not boring. I enjoyed watching it. It gives you a bunch of pointers about how to make your game better. I'll mute it just so I can show you. So basically, they have this game of Breakout. And by default, the game just is like, it's just Breakout. It's fun, I guess, but it doesn't feel that great. Like, the game is there, the game works, but besides that, it's just bland, I guess is the word I'm looking for. And as they progress through the game, well, through the talk, they add different things to the game to make it feel better. So right now they're talking about tweening and easing. That's sort of what I showed you with the damn sine wave last week, or 2 weeks ago, with that bouncy effect. That's something similar to that. But I'll just skip to the end just to show you, like, as they progress through this, where's a good point? Okay, whatever. So, as they progress through here, you see that the game just feels like better the more they play through it. I guess it's hard to tell. Okay, so as you see, there's a little bounce when the ball hits the wall, little bits of confetti as the ball hits the thing. I'm gonna stop that just in case there's any seizure warnings. I don't want that to happen. But whatever. If you watch it yourself, you'll see they add a bunch of things to it just to make the game feel better. And that's a very similar thing to this other talk. Well, this first one is Juice It or Lose It. Just look that up, it'll pop up. And then after that, we have this one. This is called The Art of Screen Shake. Although while it's called The Art of Screen Shake, he doesn't talk about Screen Shake entirely too much. But he talks about a bunch of other things involving juice that just is really good and helpful. So as you see here, he has this base game where he just shoots people, I guess. And it's a game. It's functional. But it's pretty lame, I guess. Like, he shoots them, then I guess they don't die in this version, but he shoots them, whatever. It's a game. But then as he progresses through his talk, he adds things to the game that makes it feel better. So let's see. So now he has, actually this is the introduction. This is what he had in the beginning. And then now you see after he added all this stuff, like look how the game looks now. It's the same game pretty much, but he added all these different things. And if you watch the video, you'll see the different things he does. But I could quickly talk about it now, just to show you like the things he did. He added a muzzle flash, which is just a 1-frame animation of a circle. So that's really simple. That's something you could do. He added more bullets. Well, he added a different sprite to the bullet to make it look better. Then he also added 3 bullets, just because it just makes it feel more like more is happening. It just makes it feel more alive. Like you're shooting 3 bullets. Like, oh, that's crazy. There's all these bullets everywhere. I guess that sort of changes the gameplay, but you could also balance the game around that. So you can make the bullets less strong. Make the bullets less strong because you're shooting more of them. but it just makes the game feel more lively. He also increased the amount of enemies that spawn. So there's more enemies, but they're weaker enemies. They die faster, but it just makes the player feel better about themselves because they're killing more enemies. It feels cool. As you can see, there's a bunch of particle effects everywhere. He added an explosion every random amount of times. So there's just a random chance of an explosion happening whenever you kill somebody. You can't really see it because the quality is pretty low, but he added a little jump particle effect. He added, I think it's called permutation. It's basically things that just get, like, they're just in the world that don't disappear. If you see the bullets shooting behind him, like, they just stay on the floor. Same with the dead enemies. The dead enemies are just there on the floor. It just makes the game feel more lively. Another thing he did, when he dies, he slows down time. That's another fun thing you could do. And then the last thing he did is, if you watch the talk, he talks about this. He adds, I guess, story. I forget what the word he was, but like once you die, it's like, oh, you were the monster all along. Cause like, look at all the people you killed. It's small touches like these that just add more to the game. So if we just go back to the beginning, like the game was like boring, you know, like this was the game before. Then after, like it was just bombastic, I guess is the word I'm looking for. Like, see the difference? Like the gameplay is the same, but just the touches he added to the game make it feel so much better. And that's pretty much all I want to talk about. Sorry we went a little bit over, or not sorry. I don't know if you enjoy longer ones, longer talks, but whatever. That's what I want to talk about. Like we said, this whole month is just polish phase. So I hope to see more of whatever they talk about in these talks. Yeah, sorry, not sorry. Okay. But, yeah, hopefully you add even just some of these things. It'll just make your game feel so much better. You don't have to have the best art, the best particle effects, but just having them there just, like I said, it just makes the world feel more alive. So I would definitely recommend watching these two. The Art of Screen Shake and Juice It or Lose It are the two talks. Actually, I guess I'll just post them in the chat real quick. So there's... Oh no, I gotta log in. Okay, wait. I got you. Is this... Okay. Okay, so I will post them right here. Post them. Oh, I don't have this muted. And post this one. Okay, so those are the two videos. You should watch them. They're good. So, that's that. Like I said, that's all I want to talk about. Try to add just some of those things into your projects for next week. Actually, I'll just close that. That looks weird. So, try to add some of those for your projects for next week. I promise, the videos are great. They're not boring. Okay, so watch them. At least one of them. Promise me you'll watch at least one of them. But, whatever. I'm rambling. That's all I want to talk about. So, see you next week. Your projects, like I said, they're looking great. I really like them. They're really good. So, just keep making them better. And see you next week, I guess. Bye-bye.